I warmly welcomes you to the 6th International Conference on Research in Life Sciences and Healthcare. First of all, I would like to convey my gratitude to Eurasia Research for inviting me as a keynote speaker in this conference. I am from Institute of Mathematics and Management, Sri Lanka. Mathematical Models for Forecasting Pandemic is the title of my speech today. What is mathematical modeling? Mathematical models we are using for forecasting, prediction or estimation in any field. We observed real world problems. We can see real world problems. Now what we do? We convert that real world problem into the mathematical language. It is known as modeling. On the other hand, it's a simplification of the real world situation into an equation or set of equations. And also, a model is a description of a system using mathematical concepts and languages. Now, this is the process of mathematical modeling. First, we have to observe the real world problem. After that, we have to select the suitable mathematical model. Then we have to run the model with real data and extract the predicted outcomes. After that, we have to compare the predicted outcomes and observed outcomes. If you are happy with the difference, then you can use this model for forecasting. If not, we have to go back and select another model and we have to follow the same process. The process of mathematical modeling, as I explain you with the help of diagram, and this is the process. This process divided into two parts mainly, that is model fitting and verification. Now these are the steps under the fitting. Initially, we have to observe the real world problem, select the suitable mathematical model and collect the data, run the model and extract the predicted outcomes. After you extract the predicted outcomes, you have to compare the predicted outcomes and observed outcomes. In other words, actuals and forecast. When you compare the actuals and forecast or the predicted or observed outcomes, if you feel the difference is less, you can use that model for forecasting. If not, we have to move back and select another one to achieve our objective. There are many classifications of mathematical models: static and dynamic, deterministic and stochastic. What is static and dynamic? If a model does not have time-dependent component, that model we call it static model. In contrast, if a model contains time-dependent component, we call it dynamic model. Mainly the time series models are coming under the dynamic models. The next one is deterministic and stochastic. If the models are not associated with randomness, there is no random component, that models are coming under the deterministic models. And also a model associated with randomness and variable states are described by associated probability distributions. That models we define or classified as stochastic models. Mainly the statistical models coming under the stochastic models. In a pandemic situation, there are several components to be forecast. several important components to be forecast: number of infected cases, number of death total, and number of recovered. In addition, there are so many components. To forecast everything, why we do forecasting? To identify the future behavior of the outbreak, identify the future pattern of the outbreak. That's why we do forecasting. For forecasting, we are using mathematical models. Mathematical models are the tools we use to forecast the situations. It is very economical and effective tool, and also it's a scientific approach. So that is the significance of mathematical models on forecasting pandemic situations, any pandemic situations, not only the COVID, any pandemic situations. So it will be able to identify the future behavior of the infected cases, death total, and the recoveries. And also the patterns. It will be useful to control the spread. It will be useful to examine the speed of the spread. And those decisions will be useful to, those informations will be useful to impose various rules and restrictions to control the outbreak of the pandemic. In addition, the results of the model will be a lighthouse to develop various strategies to control outbreak, such as antiviral and immunization, etc. The results of the model can be used to take initiative. It will be useful to take initiative to combat pandemic, and also for preparedness to control the outbreak. In addition, it will be useful to work out the logistic requirement, including personal protective kits, inhalers, ICU beds, etc. In addition, all other logistic requirements for both primary and supportive activities in the value chain of medical and healthcare sector. And this results of the model is useful to enhance non-pharmaceutical practices to control the outbreak. There are various types of mathematical models used by global researchers on forecasting pandemic situation, including COVID. Susceptible, exposed, infected, recovered, SCIR, and SIR, Richard, those are static models. Logistic is another static model. Moving average, including single moving average and centered moving average. Exponential smoothing, including single exponential and double exponential. Autoregressive integrated moving average, that is ARIMA. Autoregressive distributed lag model, ADLM. Trend models including linear, quadratic, growth curve, and Pearl Reed. Starting from moving average, exponential smoothing, ARIMA, ADLM, trend models. Those are time series models coming under the classification of dynamic models. Now, among all these models, SCIR, SIR are commonly used models. In addition, exponential smoothing, especially double exponential smoothers, are highly effective and successful model in forecasting present pandemic situations. In addition, linear trend models and growth curve. But ADLM rarely use a time series model. ARIMA also used and success for various situations in pandemic. Now these are the evidences or the references for applications of mathematical models for forecasting present COVID-19 pandemic. The countries focused: USA, UK, Russia, India, Brazil, Singapore, Thailand, Malaysia, and several states in Australia. The objective of these studies was forecasting number of infected cases. In this situation, double exponential smoothers, highly effective and fitted. Linear and growth curve trend models also fitted and successful. ADLM, that is lag model, also successful in forecasting number of infected cases. These studies clearly explain the pattern of the behavior, how to examine the pattern of the behavior, based on the pattern how to devise a mathematical model, how to select the mathematical model suitable to the pattern, and also how to fit the model and how to verify the model and how to satisfy the criterion of the model. Everything explained very clearly. It's very simply explained. So these papers available in Journal of New Frontiers in Healthcare and Biological Sciences. So it's very useful. Actually, it's a guideline to learn the process of mathematical modeling by reading these papers. It's very clearly and simply explained. So with that, I came to the end of my speech. If you can contact me for further information, you can go to our website. This is the website of our institute. And once again, I convey my gratitude to Eurasia Research for inviting me as a keynote speaker for several times. So thank you very much.